Okay, so in class the other day, I showed you how to do a color combination, but I figured I'd better make a recording, a video that you can reference, since I'm not going to have time to write all of these steps up, at least not right now, in the form of a manual or a guide. So we're going to rely on this video. And this is a different data set than I demoed in class. This is the Eagle Nebula. I think I used this data set a number of weeks ago. But since then, we've changed the color combination controls. And so that's why I'm shooting this video, so you can learn the new controls. Now, most of this data was taken by my summer students last summer. The Eagle Nebula is really not well positioned at the time that I'm shooting this video for observation. It's better a number of months from now, but it is observable now a little bit, beginning of each night. And so last summer, my students got red, green, blue, luminance, and H alpha. And they got that on the Prompt 6 telescope. And this past bright cycle, I made use of the Prompt 7 telescope and got some O3 and S2. So I can show you how to combine multiple layers. In fact, I think I'm going to shoot two videos. One's going to be a basic combination. And then the next one will show you some of the things you can do color-wise, because if you have three narrowband layers, then you can play with colors, right? Red, green, blue, or various other combinations. Let's keep this first video kind of straightforward, and I'll show you the different color possibilities that you have with three narrowbands in the next video. Okay, so I've loaded this thing up. I'm gonna make this available to you. I basically remade the stacks, even the ones from last summer, because we have all sorts of improvements to cosmetic cleaning and aligning and stacking. So I remade all my stacks, including the new data, and put them together into a group. And I'll share the group file with you, the videos, so you can practice and play. But let's take a look at our layers. This is S2, which I got from the Prompt 7 telescope. And it's not great. It's really noisy. You can see, well, you'll see compared to some of the other ones. This is my noisiest layer. And that's typical. S2 is the toughest one. I have probably about an hour and a half worth of data from Prompt 7 in this frame. It just shows you how difficult it is to get S2. Here's O3, much better, but this is still noisy compared to the other layers. And this is also like an hour and a half of data. This is H alpha, and it's only about an hour of data. So you can see what a tremendous difference we have in signal to noise. That's really high signal to noise, lower, lowest. But still, we're going to try to make some use of O3 and S2. Here's our luminance frame. And, this is also high signal to noise. And the luminance, you do see some of the gas, some of the nebular gas in here, because that nebular gas, it's emitting at specific wavelengths, and the luminance filter captures all of that. But the stars, they're continuum emitters, so they really shine bright in the luminance frame and in the color frames. But these narrow bands, they're narrow filters around these special wavelengths that the nebular gas emits, so it can just really pull out the gas. The stars also emit a little bit in that narrow band, because the stars emit in all bands, so you do pick them up, just not as bright. The narrow bands are great for accentuating the gas at the expense of the stars. Luminance and the color filters are great at accentuating the stars at the expense of the gas. We've got to figure out how to balance these things. Here's my red layer, also very high signal to noise. Green, it's pretty good, and blue. And blue is starting to get just a little bit grainy, and that's also typical. It's not bad at all. There's a lot of blue data here. I forget exactly how much, but well over an hour of blue data here. But it's typical. Blue is harder than green, and green is harder than red to observe, typically. Okay. Anyway, I've introduced you to the data, and now the next thing you do is get your layers in order. And I already have them in the right order here. You have the color ones at the bottom, your luminance layer. And remember, once we set this up to be the luminance layer, it will take its intensities from this layer and the colors from anything beneath it. So ignore the narrowband for a moment. If it was just LRGB, it would take its intensities from this layer, which that's your highest signal to noise layer. See all the little stars that popped in, like compared to B? Go up to luminance, all those little details and stars. You'll get all the intensities from here, but what color you color each pixel will be determined by the combination of what's underneath it. And then above luminance, put your narrowbands, H alpha, O3, and S2. And these, we will end up adjusting the narrowbands with respect to each other and with respect to the luminance. And there's some tricks that we can do for noisy images where we tuck them under the luminance, but I'll get to that. Okay, so you get this order: colors, then luminance, then narrowbands. Now, pull up my notes here, put that on the other screen. Okay, we've opened, we've ordered. Okay, we're going to set the colors and the blend modes. So the blue, we're going to color that blue. V band, which V stands for visual. It's the middle of the visual range. We're going to color that green. And R, we're going to color that red. And these all have blend modes as well, colors and blend modes. The default blend mode is something called screen, and leave that alone for the color layers. The luminance layer, and let's check these, that we actually got it. Blue, green, red. Okay. Now the luminance layer, we're going to leave its color gray, but change its blend mode to luminosity. And that's what's going to make it act as a luminance layer. It's not the fact that the filter is also called luminance. We've got to set the blend mode to luminosity. That means it will take the intensities from that layer and the colors from whatever is beneath it in the list. H alpha, for right now, we'll learn, particularly in the next video, you have all sorts of color possibilities, but right now let's color it Balmer. This is a color that I produced by taking the 4 Balmer lines for the temperatures that are typical of these star-forming regions and planetary nebulae. You have different intensities between the 4 Balmer lines. There's a red one, a green one, a blue one, and a violet one, essentially. And I combine them in their relative strengths to create a color that's typical of, there it is, of the Balmer sequence. We're only observing the H alpha line, the strongest of the 4, which is purely in the red. We could color this pure red for that reason, but whenever you have H alpha, you have the other ones. And for typical combinations of the 4, you get a color like this. Also for the narrowbands, we're going to start by changing the blend mode from screen to lighten. What lighten does is it takes whatever's brighter, this or whatever's underneath it. So here at the H alpha, in the combination, if this is a great way to bring out the gas, right? The gas is brighter in the H alpha layer. The stars are brighter in the luminance color combination, the LRGB. So by setting this to lighten, it will take its color cues for the gas from the H alpha layer, but the color cues for the stars from the LRGB, which is what we want. For O3, we're going to color this O3. That looks like this color. You can really start to see the noise in there. O3 is a doublet in the blue-green part of the spectrum. Again, I created this color specifically to match the wavelengths of that. And let's set its blend mode to lighten. And then S2, it's smack dab in the red. So we'll color that red, and we'll set its blend mode to lighten. Just check. Did I get 03? I did. Okay. Now let's go up to the top layer, and this will be the combination of all those. And right now it's rough. We still have a lot of work to do. Okay. Let's turn off the 3 narrow bands for the time being. So it's just the LRGB. That looks pretty decent, but we want to calibrate all this. So over in display settings, we're here at the combo level, the combination. Let's view the controls for the luminance layer. Here you get to pick what controls you're looking at. The luminance layer, the red layer, the H alpha layer, you can bring them up here, but continue to look at the combination in the viewer. So luminance layer, and we're going to go over here and link all layers pixel value, not percentile. The percentile, we use that with things that we cannot calibrate to background stars. This, we have plenty of background stars. Like we use percentile for a lot of planetary combination, but here we have background stars, so we're going to link all the layers pixel value. Okay. Now, basically, all the controls for all the layers they're all being linked or tied to the luminosity controls. And we can see the colors here, the blue, the green, the red, and the white is the luminosity layer. And so when we set the stretch mode and background and the other controls, it's all with respect to the luminosity layer. But wherever these bars, like this is the background level, that also will apply for the color layers. Okay, so everything is linked at the moment. When we get to the narrow bands, we'll unlink it. But right now, let's just link everything to this single set of controls. Now we're going to come down here to photometric calibration. And for the red layer, we're going to pick red. For the green layer, we're going to pick green. For the blue layer, we're going to pick blue. And we're going to measure the 0 points. So it's extracting the stars from the red, the green, and the blue layers and comparing them to catalog values. And then it's now measured the 0 points. Those are the relative factors that we have to multiply these by to get them in alignment with each other. The reference layer, we're going to set that to red. What this enables us to do, in a moment, we're going to synchronize the luminance layer to the red layer. And so this means we can come back and change the dust correction without having to resync the luminance layer to the red layer. We'll let the red layer be the basis. We're going to move the green and the blue layers to it. We're going to synchronize the luminosity layer to it in the next step. And so if we let red be the reference, we can come back and change the extinction without having to resynchronize the luminosity layer. Okay. And what I have here, 0.782, this is the E B minus V towards this line of sight. This is NGC 6611. So if I go to WebDA, change this to 6611, 0.782. We, of course, could also extract all the stars, make an HR diagram, model the isochrones, and also get the reddening. That's essentially how they got it. I'm just going to skip that step. We've already done that. 782 is what I'm going to use. And, it's not known for all star clusters. If it's not known for yours or your line of sight, you can start with like 0.75 and treat it as a free parameter and something you can come back to and tweak as you're adjusting the narrowband layers and the luminosity layer. You can go back and tweak the extinction value as well. I'm going to calibrate. Okay. See how it got a lot bluer? It's corrected. It's taken out that intervening dust, and the dust reddens the light. So once we correct for it, things get bluer. Those stars look like O stars. The brightest, hottest stars have that kind of thermal blue color. Okay. looking good. We're still under the luminosity controls, which we linked everything to this, so it's controlling everything right now. So let's move over from linear into midtone, and I'll hit the default preset. And it's a lot nicer. All the stars were kind of being saturated, not because you observed too long, just from the brightness and contrast display settings. And so this looks pretty good here. The background layer, we look at luminosity by itself. The background level is kind of right where we want, right before that peak. And I'll come back to the color combo. And you can adjust the midtone layer. If you want it brighter, you go down to 95. Now that brightens your image. Or if you want it dimmer, 99. Now I'll set back to the default 97.5. And that's something you can adjust. Once we start throwing in the narrow bands, sometimes what people do is they'll tamp the luminosity layer way down. Maybe something like this. Here it comes there, way down, and just get the stars from the LRGB combination, and everything else can be gas. I'm not going to do that here, but that is a technique. You can tamp down the stars and really show off the gas if you have good narrowband layers. Put back 97.5. Okay, there we go. Now, let's turn on our first narrowband layer. And let's take our best one, which is the H alpha. And I'm gonna, well, let me check my notes. I did miss a step. So 1 second, let me back up here. We have our combination and it looks good, but it only looks good. Yeah, I missed a step, so good thing I checked my notes. It only looks good because that luminosity histogram here kind of matches the red, the green, and the blue histograms. If it was way down low or way up high, this would not look good because the brightness and contrast controls are tied to the luminosity layer. And so if the luminosity layer is different than the color layers, basically all the color layer information would be above the brightest or below the lowest, the background level. And your image will lose its color in that case and become kind of gray. So to make sure that's not a factor, what you do, and I was mentioning this before, after you've done your photometric calibration, you're going to neutralize sources. And we're going to neutralize the luminosity layer to the red layer. The luminosity layer will most of the red, the green, the blue. It'll most closely match the red layer. I'm going to neutralize the sources. Okay. And that adjusted the histogram, the white histogram, to more closely match the red. And the blue and the green have already been matched to the red, not based on the shape here, but based on the background stars, their brightnesses, and the catalog values. So everything's as in sync as it possibly can be. You didn't notice a big change because it was already kind of in that range. Okay. So checking my list here. We've color calibrated the red, green, blue layers. We've neutralized the luminosity layer to the red layer. Now we're going, and we've done our adjustment to midtone. So now we're going to turn on the H alpha layer. Okay. You saw a slight change in color there. Now let's come over here to the controls. We're going to select the controls for H alpha, and they're currently synced to the luminance layer because we synced everything to it. Let's unsync it. Set that to manual. And we're going to hit the default preset. And let's just go to the H alpha layer. Yep, its background level is set well, so I'll leave that at 1%. We can actually set all of these right now. Well, no, we can't because things are synced. We'll do each one as we come across it. But again, for the luminance layer, background at 1% was right below the first peak. That's kind of what we want. Same with H alpha, so we'll leave that alone. Let's go back to the combination. And so we can now adjust the mid-tone. And normally what I do is I start by bringing it up to 99.999, which basically turns off that layer. And so all that we're seeing is the LRGB combination. And I can start removing nines. I actually gave it too many nines here. Start removing nines, waiting for it to come up. But eventually, if I lower the midtone level enough, it's boosting the H alpha layer. And wherever, since it's in the light and blend mode, you see that light in here, wherever it is brighter than the LRGB layer, it will shine through. So I'll take out another 9. Nothing yet. Let's go down to 95. Okay, it's starting to, if you're watching carefully, the gas here just got brighter. Stayed the same color because the bomber color is the natural color of those 4 lines. That's what the LRGB captured, was the natural color, but we've now boosted it. I can boost it more. I'll drop it to 90%. You can go crazy if you want. Let's go down to 50%. So, really, really strong. It's really a matter of taste. But notice that the stars, even here at 50%, the stars retain their natural color. Except where the gas is now brighter than the stars. Maybe I'll back it down a little bit. Let's go to 90 again. But still, I can raise the brightness of the gas. And since I'm using the light and blend mode, as long as it's not brighter than the stars retain their original color. As I make this brighter and brighter, it may overwhelm the brightness of the stars, the fainter stars, and change their colors. But it gives you some room to play without messing up the stellar colors using the light and blend mode. I guess I can demonstrate. I'll put this in screen just for a second. See how the stellar colors change? They're getting pink, and particularly if I go with the 50 percentile here, those stars they've lost their colors. There's still hints of their colors in there, but they're very pink at this point. I'll go back to 90, I'll go back to lighten. Okay, so we're keeping our stellar colors, and we've boosted the H alpha to a point that we're kind of happy with it. Now, let's try turning on the O3. Okay. It's ugly for all sorts of reasons. One, that's an ugly shade of green. We'll address that. Also, it's noisy. If I zoom in here and look at the noise and blink that on and off, it's all dominated by that O3. But it's not so bad that we have to throw it away. Let's go to the O3 controls. We're going to set it to manual. So it's no longer synchronized to luminance, and we're going to hit the default preset. Okay. I'm going to set the background level. Let's just look at the O3. I can probably raise that background. Let's go 10%. Oops, that's the layer scale. Background is here. 10%, 20%, a little bit below the peak there. And that gets rid of some of the noise. If I go back to the combination here, say that the dark areas got darker. Still, the noise in the dark area here is dominated by that O3. Yeah. So you have a couple strategies. One is you can tamp it down using the midtone. Like if I boost this to 99, that's 9. I didn't hit the second 9. 1 second. There's 99. That tamps it down. 99.9. So it's pretty much gone. Put in another 0.9, and we see no change there. So again, you can play the game of backing it out until you see something. There, 99, I see something. And, but what I see is still, it's noisy. So here's the next trick. Our H alpha layer had great signal to noise, fine. This one doesn't, so I'm gonna tuck it below the luminance layer. See that? So the color of the O3 layer is being added to the RGB combination, but the intensity is coming from the luminance layer. The intensity here is just the intensity of that, but we've now colored it with this, so we get that. Again, I'll slide it above the luminance layer. See how it got noisier? And now below the luminance layer. Cleaned it up. Now there are limits to this game. You still have to have some signal to noise in your image, else you'll get what we call color noise. The intensity will be nice and smooth, the intensity map the image, but the colors will get all speckly in the background. But our colors are pretty good here. The speckling is pretty good. So sliding that under the luminance layer really helped in this case. And again, you can play with we've set the background level, so we can play with the midtone level. And it's now been, we set it to manual. It's not linked. Yeah, right here. It's not linked to anything, so we can adjust it on its own. And just like we were doing when it was above the luminance layer, you can continue to tweak that if you want. I can go up to 95. And, it's an ugly color, but it's not noisy. I'll put it back at 99. Now the color, this is the true color of O3. And this is where it becomes a matter of taste. Particularly with narrowbands, it becomes a matter of taste. Let me change the color. You can either keep it as it would be physically, or you can change the color. In my next video, we'll show you a variety of color options where I'm not going to worry so much about the noise of my layers. I'm just going to show you the different color possibilities. But it looks, greens are kind of dangerous and they can look really ugly. So we're at O3. I have one called blue-green that's a little bit more blue, a little bit less green. And so I just changed the color to that. Maybe I'll adjust the mid-tone level here, pull it up a little bit. Whatever you want. Maybe that's too much. Let's go back to 99.99. Let's turn it off for a second, bring it up slowly. It's 99. So it brings it in a little bit, gives you some color variation. It's not blanket pink, and it's a little bit more tolerable than the O3. You could also go straight blue. Some people do that, and you're going to have more of a purplish nebula in that case. I'm going to go with the blue-green. I like that one. Oh, just a little something while I'm on this here. You may have noticed with the two brightest stars in this image, I have saturation bleeds. I have one here and this one here in the alignment. When I made the stacks and aligned them, that created some problems there. These kinds of defects, when you're all done, you'll go in, after you export your image here as a JPEG, you can go in and do pixel by pixel editing in whatever software tool you want and just edit out those pixels. Let's mention that since I saw it. Okay, let's try our worst layer. I'm going to turn on the S2 and I'm going to go to the S2 controls. It's currently colored red, which is its natural color, but you see it's really noisy. You see that there? What can we do? Well, first we're going to unlink it. Okay, it's set to manual. And I'll hit default. Okay, you can really see the noise now. And let's look at this layer here and increase its background 10%. 20%, 30%. I'll even go up to 40%. That helps a little bit. Let's go back to the color combo. See how it darkened that there? And then you're going to want to increase the midtone level until at least the noise is not there. Let's go to 99. See, it's still there, 0.9, 0.99. It's not much change. So if I back it down to 99, don't really see much going on. I drop it to 95. Still, it's not really shining through. 90. I think I might see a little bit of change there. Yeah, 90, it starts to come through. It's just really faint. I'll put it at 99. But even there, the noise is just terrible. So let's try our trick. Let's try our trick. We'll slide it below the luminance layer. Boom. The noise is gone. It's just color noise at this point. Again, the noise is set by the luminance layer. If I turn this layer on and off, you can see most of the red speckly is color noise from that layer. Most of the green speckly, that one's actually pretty good. Blue speckly is coming from the blue layer. Okay, so I slid it beneath. And now let's try to bring it up and see what it looks like. Let's go to 90 here. Okay, and so you did see red kind of creeping in. Though, you know, that color noise is pretty gruesome. If we want to get rid of the color noise, then we've kind of gotten rid of the signal. It's just so bad of a layer, it's not working. Like if I drop down to nothing, I don't really see any difference. So when you're really desperate, there's one more thing you can do. You know, if you're, oh, I set it to 9. That really brings out the noise. Okay, so, you know, first trick for hiding the noise is slide it under the luminance layer. But even there, the color noise was too bad. And so we can switch out of the light and blend mode to screen. And so with lighten, it's taking whichever is brighter, S2 or the stuff beneath it. And we had to set it so low that the stuff beneath it was always brighter. We use screen, it's always going to be averaged in. So this is a way to definitely see the S2. It will show up. If you make it too bright, it will contaminate your stellar colors. So the trick is not to make it too bright, right? If I do something like that, right, it's too bright and it's bleeding in, changing stellar colors. And I mean, 9 is just horrible. Let's go to 90. So I should go 99.999, and then we'll ease it in. 99.999, it's essentially off. I'm going to start taking out 9s until, and each time it's going to brighten it a little bit. It's not like with lighten, where it's either there or it's not. It's being averaged in. It's just greater and greater levels every single time. Maybe 99.5. And we can blink it on and off here and see its effect. There it's off. Here it's on. So just a real subtle reddening, but we were able to make use of it. It really highlights, like right here. Turn it off. See that? Turn it on. Really gives it a nice highlight there. And if we look at the layer, that's pretty much the only thing good that came of it. There's some light in the stars, and hopefully we haven't added so much that it's changed the colors. But otherwise, it's kind of an outline that it's providing between the hot, low-density gas and the high-density cloud around it. I should also point out over here, I have sync orientations on and sky on. Don't turn on sync display, but sync orientations and sky. And that's how I've been able to hop back and forth between different layers and have them be in the same place like that. So it looks pretty good. I actually used all my layers. using natural colors for the most part. I did tweak the 03 because I found the 03 color a little annoying. I made it a blue-green color instead. Let's double check. Yeah, but otherwise pretty good. And download it here. And let's get it in the proper orientation in the sky. Yeah, that's the proper orientation in the sky. It looks pretty good. And in a little while, I'll shoot another video about incorporating the mid-infrared and the near-infrared. And so this is going to get even more interesting as we incorporate those archival, some of them are space-based observations into this. But for now, I'm pretty happy with it. I got natural stellar colors. The only thing that I'll do, I'll save a copy here. Maybe I'll open this up in my favorite program, Microsoft Paint. I was mentioning this before. This stuff right here. You can edit this stuff manually. You can grab like a nearby color, then color it in. Grab. Like that. If you want, you can even edit out the bleeds, not just the crazy stuff, but the bleeds there. And you can do a better or worse job, depending on how much you care. This one has some stuff too. No, it's gunk on my monitor, but there is a little bit of bleed here. So you can do the same game if you wanted to. You can cut the bleed back a little bit. Okay, let's see what that looks like. Yeah. Probably could have done a better job with those edits there, but you get the idea. All right. I'll stop this video.